Hello students, in today's video we are going to study about mechanism of corrosion. Corrosion is a process, it's a spontaneous process between a metal and various compounds and elements which are present in the air. So that particular metal which is there, and then all the other chemicals, all the other gaseous substances in the air will combine together either in a chemical way or a biochemical way or in electrochemical way, and all this happens spontaneously. It happens without any human intervention or with the help of any kind of energy provided by humans. So how does this actually happen? What are the different factors which make this happen? The entire mechanism, the entire process of it, we will study in this video. Mechanism of corrosion. There are two factors that influence the rate of corrosion. So now whenever we are talking about the rate of corrosion, we are talking about the speed of corrosion. Now this particular speed of corrosion is actually influenced by two different factors. Hence, a knowledge of these factors and the mechanism with which they affect the corrosion rate is essential. So if we know that the entire speed of corrosion is affected by only two factors, then for us it becomes very easy to know those two factors. It is very crucial so that we can try to control those factors and keep the different metals from corroding. Essential because the part of corrosion is different in different atmosphere. So always remember, metals will react differently when they are placed in different atmospheres. That is the importance of corrosion. What are those two factors? The first factor is the nature of metal. What is the nature of metal? Is the metal very destructive or very active when it comes to the interactions or chemical reactivity with different gases, or it is not reactive, it is passive? I will give you an example. Let us take two metals over here. The first metal will be iron and the second metal will be gold. We all know that iron catches rust very quickly. But when it comes to gold, gold does not decay or decompose at a very fast rate. Of course, gold will also react, but it takes tens of thousands of years for gold to actually react with something. But when it comes to iron, iron can easily react and very safely react. That is why nature of metal is very important. Second important factor is the nature of the corroding environment. In which environment is exactly this entire process happening? Again, I will give you two examples over here. Let's consider two cities. The first city can be a city which is very near the coast, and second city can be inside the land. That means that city is in the middle of the land. If there is city A and city B, city A has a lot of humidity, a lot of salt, a lot of wind in the atmosphere because it is a coastal region. City B is in the center of the land. It does not have a lot of humidity. It has dry air. So now, whenever there is moisture, moisture always acts as a catalyst when it comes to rusting of iron. So whenever there is moisture, iron will rust very easily. And when there is no moisture, iron will not rust that easily. So if I have two pieces of iron, one in the city which is near the coast and one in the dry city, the rusting will happen very easily and very quickly in the coastal city rather than in the dry city. Thus, the corroding environment is also very essential when it comes to the mechanism of corrosion. Let us first focus on the nature of the metal. The first is nature of metal. Physical state. Always remember, metals are generally solid, but there is a metal mercury which is liquid in state as well. But apart from that also, its physical state, the details of the physical state are very important. So let's look into the details of it. The rate of corrosion is influenced by physical state of metal such as grain size, orientation of crystals, stress, etc. Now, what do we mean by this? Grain size. That means the size of the grains, that means the size of the different atoms, the different molecules of that particular metal. Orientation of the crystals, how are the crystals, that means how are the different subatomic or the atomic particles oriented. And finally we have stress, the stress which is applied to it. For example, let us take aluminium. You can see a sheet of aluminium as well, and you can also see a utensil of aluminium. A sheet of aluminium is very thin, you can just break it or tear it off with your hand, the aluminium foil. But when it comes to the utensil of aluminium, you cannot tear the utensil with your hand. So again, the physical state of it is very important. Even the aluminium foil is solid in nature, even that particular utensil made up of aluminium is solid in nature. But that does not mean that both of them are same. That does not mean it is easier to destroy one and not to destroy other. Destruction, rust, any kind of interaction also depends on various kinds of physical dimensions. The smaller the grain size of the metal or alloy, the greater will be its solubility, and hence greater will be the corrosion. It's very simple. If I have a small grain size, whether it is a metal or an alloy, what will happen? It will get easily soluble in presence of moisture, in presence of any liquid, in presence of different gases. And because of that, what will happen? Corrosion will be much easier. Moreover, areas under stress, even in pure metal, tend to be anodic, and corrosion takes place at that areas. So now again, if I have a lot of stress applied, they are anodic in nature. That means they will react with anodes in presence of anodes. Now what do we mean by anodes? There are two electrodes, cathode and an anode. Cathode comes and it forms cations near it. Cations are positive ions, and node will come and react with negative ones. That means negative ions, if there are negative ions, free electrons inside a metal, they will be anodic in nature, and because of that the corrosion will take place. Second important factor is purity of metal. Now metal can be of various purities. Now how can we determine the purity of metal? Whenever we find a metal from the earth's crust, when the particular metal is removed from the earth's crust, it is always impure in nature. It is always mixed with oxides and sulfates, nitrates, different kinds of chemicals. Everything is mixed in it. But once we purify it with the help of metallurgy, we finally get a pure metal. Now that purification can be 80% purification, 90% purification, or 100% purification, based on the factories, based on the industries, based on the different kinds of processes which are done. So let's see the purity of metal and how it affects. Impurities in a metal cause heterogeneity. Now what do we mean by heterogeneity? In chemistry there are two things: homogeneous, heterogeneous. Homo means same, hetero means different. So if I say I have a homogeneous substance, that means that entire substance is made up of same kind of elements or same kind of compounds. But if I say I have a heterogeneous substance, that means that entire substance is made up of different kinds of elements. And if I have a metal which has impurity, then that particular metal will have two things in it: the metal itself plus the impurity. That means it will have two different things, and in chemistry different is known as hetero. Thus we call it heterogeneity, and form minute tiny electrochemical cells at the exposed parts, and the anodic part gets corroded. So with the help of different impurities, corrosion takes place very quickly. The 10% pure metal will not undergo any type of corrosion. So if I have any metal which is 100% pure, that will not undergo corrosion. So now there is a question that if 100% pure metal does not undergo corrosion, then why don't we make all the machines with 100% pure metals? Why don't we use 100% pure metals into our day-to-day use? That's because 100% pure metals are soft in nature. You cannot make strong devices out of it. For example, if you want to make a building, you cannot make it from 100% pure iron, because iron itself, when it is 100% pure, it is very soft. It will not stand in the structure itself. For example, the rate of corrosion of aluminium in hydrochloric acid will increase in the percentage of impurity noted. So if I have aluminium, the percentage of purity is 99.9999.9997992. The relative rate of corrosion is 1100030000. So now that is the relative rate of corrosion. So in short, the purer the metal, the less the corrosion. Moving on to the next factor is over voltage. Voltage comes from the terms of electricity. So if I have machines working on electricity, if I have various machines through which electricity is being passed, and that electricity is actually making the different parts or the mechanisms of the machines to work, then because of the voltage, corrosion might take place. The over voltage of a metal in a corrosive environment is inversely proportional to the corrosion rate. Remember this, it is inversely proportional to the corrosion rate. For example, the over voltage of hydrogen is 0.7 volts. When zinc metal is placed in 1 molar sulfuric acid and the rate of corrosion is low, when we add small amounts of copper sulfate to the dilute sulfuric acid, the hydrogen over voltage is reduced to 0.33 volts. This results in the increased rate of corrosion of zinc metal. So what is happening over here? There is over voltage of metal and it is in a corrosive environment. It is inversely proportional to corrosion. And over here we have got the example of hydrogen with zinc metal with 1 molar sulfuric acid and also copper sulfate to dilute sulfuric acid. Finally, we have nature of surface film. Now, what do we mean by surface film? Surface film is nothing but a film which is present on the metal surface. Now, if that particular surface film is very reactive in nature, then there will be a lot of reaction happening between the metal and the various gases in the air. If that particular surface film is not very reactive in nature, then there will be less things happening over there. Thus, the nature of the surface film is also very important. In aerated atmosphere, practically all metals get covered with a thin surface film. Thickness is equals to a few Armstrongs. Now, Armstrong is one of the smallest unit. That means the thinness or how thin that particular surface film is actually going to be very, very thin. The ratio of the volumes of the metal oxide to the metal is known as a specific volume ratio. So now if you have a metal oxide and you have a metal, the ratio of the metal oxide to the metal is known as specific volume ratio. Greater the specific volume ratio, lesser is the oxidation corrosion rate. So if you have a very good ratio, the oxidation rate will be comparatively less. The specific volume ratio of Ni, Cr and W are 1.6, 2.0 and 3.6 respectively. Consequently, the rate of oxidation of tungsten is least even at elevated temperatures. So tungsten itself at even high temperatures will have a very low ratio, that is the specific volume ratio. Moving on, we have relative areas of anodic and cathodic parts. So whenever I am talking about an anodic part or a cathodic part, I am talking about two electrodes. There are two electrodes, anode and cathode. Cathode is the negative electrode, anode is the positive electrode. Cathode will attract cations, anode will attract anions. When two dissimilar metal or alloys are in contact, the corrosion of the anodic part is directly proportional to the ratio of areas of the cathodic part and the anodic part. Always remember, any kind of metal or any kind of alloys will have two things, cathode and anode. So now cathodic parts and anodic parts are present. So now we'll have anodic part to cathodic part, the ratio will be there and the ratio will be present. Corrosion is more rapid and severe and highly localized if the anodic area is small. So if you have anodic area which is very small, then corrosion will happen very rapidly. Example over here is taken a small steel pipe fitted in a large copper tank. So copper tank becomes my large cathodic area and small steel pipe becomes my smaller anodic area. Thus, what will happen? Corrosion will take place. Because the current density at a smaller anodic area is much greater and the demand of electrons can be met by smaller anodic areas only by undergoing corrosion briskly. Now, what do we mean by that? If you have an anodic area and a cathodic area, it kind of creates a voltage difference. And if it is creating a difference, there will be two sets of ions, cations and anions. And if I have a larger cathodic area, that means if my cations are high, I will have to produce more and more of anions. And to produce more and more amount of anions, I will have to give in more and more amount of reaction. And that reaction is nothing but the corrosion reaction, which leads to corrosion. Position of galvanic series, passive character of metal, solubility of corrosion products, volatility of corrosion products. Now, what do we mean by this? Apart from all of this, there are some different factors as well, which is the position in the galvanic series. Galvanic series is the series of different elements stating which element is higher and which element is lower as it comes to reactivity. Where the reactivity is higher and where the reactivity is lower is important. Then we have the passive character of the metal. So passively, how will that particular metal work? If the metal is not kept actively, but it is kept in the background, how will it affect? How passive it is, how active it is, even that is important. The third is solubility of corrosion products. So if I have a corrosion product, for example, rust is a corrosion product. And if that particular corrosion product can easily get mixed in water and washed away with water, then there are high chances of new corrosion products to be formed. And finally, you have volatility of corrosion products. So at times when the corrosion products are being formed, they are volatile in nature. Now, what do you mean by volatile in nature? Products which can easily evaporate in the environment without any external intervention or any elevation in the temperature are known as volatile products. So again, volatility of the corrosive products is also an important factor. Thank you.